Let me review a couple of things here. Oh, scheisse. A couple things you need to know to go into that problem, right? 66.5.1. If I gave you a profit function, remember we did this before? How would you find the maximum profit? Let me start off, let me ask you that. So why is there a maximum? How do I know there's a maximum? What shape would this take if I graphed it? Everybody trace it out in the air. Try. All right. Is there a top point on the shape you just drew? Yes. Bless you. Sorry. That was so cute. There's a top point on that graph, correct? You with me? If I graphed it, that graph would represent profit. The question is, what's the maximum profit? So graphically, what's the highest point? Yes? And what is the highest point known as, of course? Vertex. And what's the shortcut to find the vertex, the x piece? What's that little beautiful formula? Negative b over 2a. We talked about where that came from before. So b would be 400, is that cool? And a is negative 0.01. So it'll be 200, it'll be 20,000. 200, 2,000, 20,000. Somebody can double check me on that. Boom, 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 boom. Yes. Okay. Right, and what does that mean? That just means the number of things I have to sell. It doesn't tell me the max profit. So how do I actually find the profit? Well, if I know X, how do I get the profit? If I know X, I just plug it in, right? Okay, so that's its own idea, right? So all number 66 does is it says, I am going to give you the equation. You're going to make it yourself, right? So it doesn't give us this. We have to create it for number 66. Everybody's favorite, right? Word problems. Yay. Okay. So on 66, here's what it tells you, right? You would plug this in, blah, 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 blah. Okay. 66 tells you you have 200 feet of fencing. That's what they tell you. And they ask you about the area. They want to find the largest area you can create if you have 200 feet of fencing to make a rectangular area. You guys with me? So you have a certain number of fencing, a certain amount of fencing, and you want to make the largest area possible. So for example, couldn't I make it like this? Couldn't I use the fencing like this? 1 foot, 1 foot, and that would leave, you could do it, Jeff, 99 and 99, yes. Couldn't I do that? 1 foot of fencing, and then 99 foot of fencing, and then 1 foot of fencing. Is that going to be the biggest area? So somewhere there's a sweet spot, right? Somewhere I can get it so that it is the biggest area possible. Are you guys, do you see that? So that's really what this question is asking. What's the sweet spot? If I have 200 feet of fencing, what's the sweet spot to get the biggest area?
Circle.
I love it, but you have to, it's got to be rectangular. Now, real quick, I love that somebody said circle. Do you guys know what a silo is?
Mm-hmm.
Yeah.
What's normally in silos?
Grain.
Grain. Little things that'll fill up a volume completely. So if I have a certain amount of material, the best shape to make to fit in little granular pieces of things is a cylinder because it's circular. A circle has a larger area than a square that has the same perimeter. So we just sort of naturally figured it out. We actually didn't use math. We're like, well, these seem to hold more, so we're going to make all of these things cylindrical. Are you guys semi with me? All right. So why aren't moving trucks cylindrical? Because we shove cubes into them. So of course I want the moving truck to be rectangular so the cubes can fit in there. Okay, so that's a side note. So 200 feet of fencing. What geometrical idea does that relate to? Okay, what about the rectangle? Does it relate to the volume? You can't even have a volume, right? 200 feet of fencing would relate to the perimeter. So the perimeter is 200, yes? So let's draw a rectangle. What are the unknowns about this rectangle? Length and width. But from this, how do I know that these must relate? From this fact, I know the perimeter is 200. How must these relate to each other? Say what? Where do you get that from? So the perimeter has to be 200 feet. Yes, the perimeter has to be 200 feet. Yes?
Yeah.
What's the formula for the perimeter of this rectangle? Almost. 2L plus. You just kind of walk around L plus W plus L plus W. Right? That's got to be 200, yes? We know that shit. We know it. That is the only thing we know. That's all they told me. And of course, you know, it's filled with variables, so we sort of don't know it. But that I know that relationship, right? Now, what's the formula for what they asked me? Now that we've given variables, what formula do they ask me to look at? L times W. Okay. And what really sucks about both of these formulas is how many variables are they dependent on? So what is the perimeter dependent on? How many variables? 2. The area is dependent on how many variables? 2. It sucks. I don't want that shit. I want a function of one variable, then I can do stuff to it. Too many variables, I don't know what to do. So can't you solve this for one of the variables and then put that in here? What you're going to end up with, if you do that, solve this for L or W, it's up to you, and then shove it in here. And what you end up with is a quadratic. And the largest area will be the vertex of that. And we have a shortcut to find the vertex. Are you guys semi with me? Can you solve this equation for W or L? I don't care.
L equals W times 100? Is that right?
Well, first off, I can divide everybody by 2, right? And then I can just subtract one of the 2. So I'll solve for L. L is 100 minus W. So wherever in the universe of this problem I see an L, what can I replace it with? Because L is freaking 100 minus W, yes? So I see an L right there. So what can I put there? Yeah, and then you distribute the W. You see how you get a quadratic? You see how you get a parabolic sucker? And then you know you want to find the vertex. And you have the shortcut, the negative B over 2A. Okay, that's all I'm going to tell you. That's more than we probably knew going into this problem. But these kind of problems, I love to look at it as they tell me something. Okay, let me write the math shit related to what they tell me. And they ask me something. Okay, let me write the math shit related to what they ask me. And then I see how they can be used together. Be good. No.
So then you distribute?
Yeah, distribute. You see how you're going to get a W squared piece? It's going to be quadratic. You can identify A and B. You can find the vertex. Okay. Maybe.
But you wouldn't want it to be 100 minus W times 100 minus L?
Hell no, because then you still have 2 areas. So don't walk past yourself.
Okay.
Only replace one of them. Yeah. Because I want area to be a function of one letter. So if I replace L with 100 minus W, now it's just a function of W. It's just a function of width. And I can do more shit with that. Right? We don't know how to work with multivariable functions too well. Okay, all right, well, okay. Anything else from homework stuff? Where should you be at the moment? You should definitely be getting into 5, if not already into chapter 5. right? The test is through 5-4, so if it's getting to be like Sunday and you're in 5-1, maybe start doing like I suggested. It's up to you. It's your decision. Start doing every other problem I assigned, right? Don't, and I love it, students will turn in and they did like the first 4 problems. And they said, well, I tried some, like you told, no, first 4 problems are gonna be not representative of all the ideas. That's why I'm like every other problem maybe. Get a nice swath of the problems. Okay. Anything else? Everything else is great?
Just really behind.
Does everything suck? Does everything suck? Is everything shitty? Is everything terrible? No? Is everything meh? Is everything meh? Meh. All right. I'm not gonna tell you, Joe. All right. Okay. Mohammed, did that help you out a little bit? Yeah? Okay. Okay. So last time we finished section 5.3. Let me see if I want to show you. Here we go. Get there. Yeah, this is where we're talking about end behavior in a larger context. Blah, blah, blah. Here we go. So let me get a decent problem to try to look at. Yeah, this looks funky. I like this one. Ooh, that's gross. All right, maybe not that one. Yeah, no, not that one either. This one, okay. All right, let's try this. So let's do one quick example of the problems we were looking at last time. So of course, some of the problems are going to start off not factored yet. You're going to have to factor them first. What does factoring do for you? What can I just tell just by looking at this function, now that it's in factored form? Say again? Sorry, say again?
The point is going to go through a term?
Going through a term?
Yeah, the points.
The points, what kind of points? I can see some points.
Yeah,
Where they hit the x-axis, the x-intercepts, right? Because what are x-intercepts supposed to do? When you plug in the x value, it's supposed to make the function 0, right? X-intercept is where y equals 0. So what are my x-intercepts? 3, 0, and negative 1, 0, right? Is that cool? That's what makes each of those things 0. Are you guys cool with that? I mean, if I make one of these pieces 0, the whole damn thing's 0. Maybe. So again, I really want to. X-intercepts have the x value that when you plug them in, it makes the output 0. Right? In fact, that's how we find them. Don't we make y 0 to find them? Yeah, so the x values that make this 0 are 3 and negative 1. So the intercepts are 3, 0, and negative 1, 0. What about the multiplicity? What's the multiplicity of each of these? Jeff, what is that? There's a question mark.
2.
Yeah, 1, 2, and this is 1. So what's it going to do at this intercept? Is it going to go turn or is it going to go through? It's going to turn through. Some of my colleagues call this, it's going to bounce. But to me that just sounds like it's going to like, I'm out of here. But, you know, if you like bounce better, it's fine. I like turn, it doesn't matter. All right, that's one of the new things we introduced yesterday. Was this idea of multiplicity and what it means graphically. It's a beautiful shortcut. You don't have to do as much work. Always nice. What about the end behavior? What's the degree of this? And again, do not multiply it out. It's crazy. What's the degree of this? What would it be? Sorry, do it. Third degree. Right? Can everybody see this would be third degree? Is anyone like, how the shit do you people know that? Is anybody like, yes? Okay, beautiful, thank you. If I multiply this out, wouldn't the highest power be squared?
No.
Right, if I FOIL x minus 3, right? And then I'm gonna multiply that by that, so the biggest power overall would be third power.
Okay.
So you shouldn't have to multiply it out. You should be able to just go, what would happen if I did? The biggest x would be the biggest x from this and the biggest x from this. Third. Kick the ass in. All right, I like it. So it looks like x cubed. So the end behavior is going to be, what's it doing over here? Or, oh, okay, we got to turn around because so many guys are drawing. Yeah, so it's like that, right? Is that all right? What's a cubic look like? Does it look like this? So why don't I just draw this? Because I don't know what it's doing in the middle. I know what it's doing at the ends. In the middle, it could be doing weird shit. At the ends, it's got to eventually be going like that. Okay. Okay. All right, so let's fill in some details. We've got the x-intercepts. We've got the end behavior. What about the y-intercepts? And you get the y-intercept. To get the y-intercept, you set x to 0. So what happens when you make x 0? So it's 9, right? Negative 3 squared 9 times 1. So you get 9. So each of those things is its own little problem, right? End behavior. You have to think, okay, what's the highest degree? Okay, so I know, okay. X-intercepts, okay, is it factored? I got to factor it, and then I can see what the x-intercepts are, great. Multiplicity, okay, I can go, now that I got to factor it, I can see what the multiplicity is, which tells me what the hell it's doing. Those are each separate steps. Now that I got all this information, I can start to fill it out. I can see what else I might need to know. Okay. I don't know what the scale is going to be yet. So 0, 9, I at least need to be able to get up to 9. Maybe I'll give myself a few more just in case. So let me plot my intercepts. 3, 0, negative 1, 0. I'm not going to make my y-axis scale yet. I know it's going to come like this, and then here it's going to go, here. It's going to go through. Is that cool? Yes, so it's going to come like this. It's going to go through, and then it's going to bounce there. So what would be a good function value to get? So I know it's going to look like it's going to go through, and then it's going to turn. So what would be a good point to find? What x value would lead to a good point to know? Considering it's going to do this, or is it going to do this, or is it going to do this? I don't know. What should I look at?
3.
Say again?
3.
What about 3? We already know 3 is 0, right?
1.
Yeah, I want something in the middle here, yes. Are you guys cool with that? I mean, I'm not going to draw anything yet, but I know it's coming up like this, right? I know it is. But I'm not going to draw it yet. I know it's coming up. It's going to go through negative 1, 0, right? And it's going to come back to 3, 0, and then it's going to turn. So I'd love to know how high it gets in here, right? Just to kind of improve my graph a little bit. So yeah, 1 is a good idea. Let's see, what's f of 1? What do I get when I put a 1 in?
Negative 2.
Yeah, 1 minus 3 is negative 2 squared is
4.
4 times 1 plus 1.
Good.
So 4 times 2?
8.
8. So I know 1, 8. So it looks like I've got a 0, 9. I got to get up to 8. So maybe I can make this by, it doesn't matter, 2, 4, 6, 8, 10. Yeah, that's fine. So now I can figure out my y scale. Do you see what I'm saying? You don't have to figure out your scale first. You can figure it out almost last, right? So now I can plot my y-intercept. I can plot my f of 1. So now I know it kind of does like this, right? It actually, strangely enough, it's going to have to, well, let's see, this is really strange. 2, 4, 6, yeah. 1, 8, 0, 9. It's a little bit, that's funkadelic. All right, so it's going to start going up, and then it's going to have to turn pretty quickly. Now, I think it probably, I don't know. This guy's really interesting. And then it's going to turn here. It's kind of a stretch there. It's kind of stretched out there. And how do you check that? Yeah, put it in your graphing calculator. So the biggest mistake you guys make is you'll do work, you'll copy from the graphing calculator, and your graph does not match your work. That's the way to lose the most points. Yes?
How'd you get 8?
1 minus 3 is negative 2. I plugged a 1 in, right? 1 minus 3 is negative 2 squared is 4. 1 plus 1 is 2. 4 times 2 is 8.
Oh,
Yeah.
okay.
So I just plugged a 1 in. And you could have plugged a 2 in, you could have plugged a whatever. I just needed another point in here to see where it went. I'm really curious what 2 minus 3, so 1 times 3, so at 2 it should be at 3. So somehow it goes, I think my scale sucks a little bit more. Maybe that's what we did yesterday. All those parts. In each part, on a test or something, I like to set it up where I just do each part by itself, so you can sort of, each part is its own problem, right? Which part of that makes the least sense for anybody? Somebody out there's like, everything on the board. Yes?
I just wasn't here yesterday, and
Oh,
so I don't
shit.
understand the concept of multiplicity. Like, what is it?
So this piece by itself, do you see how it's parabolic?
Uh-huh.
And actually, it's just the fact that it's got an even power.
Okay.
What do even power things do?
Got it.
So that's why I have the multiplicity. All the multiplicity means is the degree of that individual term. So if it's even, it's going to turn like a parabola would. If it's odd, it's going to go through like a cubic would.
Okay.
Yeah. Maybe. And do you see how it goes through this almost like a straight line?
Mm-hmm.
And isn't this linear, this piece? Yeah. Okay.
Okay. Oh, so it just goes through the point, and then if that was an even power, then it would have curved back up again?
Which one was the
At -1, 0. So if it was x plus 1 squared, it would have turned again?
Well, that's a shitty one. Let me get you a better one. Here's the handouts from yesterday.
Thank you.
Anybody else need the handouts from yesterday? Yeah? Now, of course, this doesn't have explanations, but if you go to the video from yesterday,
Mhm.
you can kind of follow along. Okay. All right. So of course, a big part of this is being able to factor what you're given if it's not already factored, right? So you have to know all those various methods of factoring just to get it here. On a test, let me just say on the test, right? I will tell you to verify that this factors like this. So in case you can't do that, you can just take the factored form and do everything else. Because if you screw up the factoring, the whole thing is wrong. Does that make sense? Okay. So I'll tell you what the actual answer is. I'll just ask you to show me. All right. So let me see that would have been good to prepare us too bad. If I ask you to factor this here, All right, take a second and factor that. I'm gonna make another more evil problem. Let's see. Take a minute and just factor that for me. Yeah, okay. Think that'll work. Yeah, okay. Get that up. Love it. All right. So what method are you guys using to factor this? Yeah, there's 4 terms. You do grouping. What comes out of these two? Good. X squared. So 2 less x's. Took those 2 x's, so it's just a 7. What comes out of these guys? 2. And then of course x minus 7. And these are the same, which tells me I can do the next step. Can I factor this one any further? Not using real rational numbers, no. Yeah, I like it. Okay, so that's that sucker factored, right? So that's this. What about if I ask you to factor, something weird's gonna happen. Yeah. Is it plus? Yes. Can anyone quickly see that the method we just used will not work? I mean, if you take an x squared out of this, it's never going to look the same. The piece I'm left with here is never going to look the same as what was over there. Can you guys see that? It's never going to match up. So I can't factor it like this. But this is factorable.
Group the cubes together.
Oh, like this?
Mm-hmm.
That's a good idea. But it still won't work.
Okay.
Damn it. Damn you, Jeff. So, I understand. I hope some of you guys will appreciate, I'm going to give you another tool to be able to factor more than we currently can. That is factorable. It's completely factorable. Just we don't have the right method to do it yet. So I'm going to develop that method with you. And I'm going to remember this guy. We're going to do this guy here in a minute. Actually, we're going to do this guy right now. Okay. Let me write him up here. So real quick, you guys. Most likely, this came from something that looks. Are you guys? Is this cool? Wouldn't this have come from something like that? Possibly. Yes. Maybe. I love it. Can anyone tell me anything about the numbers that would be here? There is something that they have to do. Say again? No? Close. There is something about the 8. If you FOIL this business out, where would the 8 come from? This times this times this, yes? Right? Are you guys kind of with me? Isn't that where the last thing always comes from? It's always the multiple of all the constants. Where did the x cubed come from? X times x times x. So where does the other extreme come from? Just the constant. Constant times constant times constant. So could one of these numbers be 5?
No.
Hell no, because it's not a factor of 8. So give me numbers that could be here. 2. Give me another one. Sorry. Sorry. Give me number 2. Give me another one. 2. 4. 8, right? Could it be 8, 1, 1?
Yeah.
And of course, I just gave it away. There's another one. 1. And they could be plus or minus, correct? Could you create this list no matter what number I put here?
Mhm.
Shit, yeah, right? Okay, maybe. Do you guys get that idea? And again, this is something we kind of know, but we just never used it that directly. Especially not for cubes. We use it hell directly for squares, right? In fact, I really want you to point this out. Real quick, how would you factor this? What would you do? What we go here and here? Because x times x is x squared. What numbers have to go here? What must those numbers do? Don't tell me what they are. What must they do? They must multiply to be this guy. Oh shit! So what must these numbers do? They must multiply to be this guy. Are you with me so far? Okay, I love it. You're all like, dude, I don't like factoring already, and you're gonna freaking give me another shit. No. This one's kind of interesting because it's got broader implications than just factoring. Now, because okay, you're gonna love the hell out of me. Does everybody get that idea? So now we have this list of possible numbers that could go here. We are not going to trial and error this thing. We'd all go insane. It could be 1, -2, and 4, and then you do no. Oh my God, how long could it take to get there? Long. Okay, I'm going to take this away. All right, is everybody cool with that so far? Right. So if I had a 10 here, this would be plus or minus 1, 2, 5, 10, right? 1, 2, 5, 10. Okay, maybe. Now, I'm going to do something that seems unrelated. Oh, you guys are going to love the hell out of me. So, yeah. Okay. This seems unrelated, but it's very, very related. Can you long divide that by hand, please? You're like, excuse me, Jeff, I have left that stuff far behind me. I have a calculator. I don't give a shit. Can we do this long division? It's been a while for some of us. Does anyone do long division different than this? Is that the way everybody does long division? Every now and again I have somebody that comes from a different country and they actually do long division in a different format. And it's been so long I forget how it is, so hopefully, okay, good. Now help me out, guys. Can somebody, now think about it. Are you thinking about it? What's the first thing you're trying to come up with to start this long division? An excuse to go home, no. What's the first thing you're thinking about? Come on, tell me. Right, you're trying to figure out what number to put up here, yes? So how do you think about that? What do you look at? Say again? Does 7 go into 50? That's what I think, right? Does 7 go into 50? Not evenly, but does it go in? How many times? 7. So then you put that up here. And if you ever really watched your thought process when you're doing long division, that's exactly what you do. You don't look at the whole frickin' 71. We look at the first parts of it. 7 times 71 is 497. Right? And then what do? That's right, change the sign. Change the sign, right? I'm a weird math teacher. I know it's subtract, but didn't I just change the sign? It's going to become very important in a minute. So what's 504 minus 497? I like it. No.
78.
What's happening? 504 minus 497. 7. Thank you. Isn't 497 3 away from 500? And then it's 4 away from 504? So that's 7, right? Okay. And then bring down the 8, yes. And then 7 goes into 7 once. Oh, this is weird. I just randomly picked this. This is kind of awesome. 1 times 71 is 71. Change the sign. And then what's this? Please don't tell me big R. Hello. How do I write this? information?
Added decimal?
Nope. I don't want decimals. What's the other way to write it? Right? 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 Right?
It's been so long.
I know. Okay. Like if I asked you to make this into a mixed number, isn't that how you do it? 8 goes into 15 ones with 7 left over, yes? Don't we, that's how we write remainders now, that we don't make big ass R anymore? Okay. Is everybody with me so far? So we'll look, watch what we're gonna do, okay.
Let's see, what's it for?
Say again?
5084?
Yeah, that's, 71 times this is this. I'm kinda glad you just said that. So what can I do? I can say 5084 divided by 71 is 71 and 7 71s.
Looks like this is division, says 5048.
Oh shit, I'm sorry. Yeah, I transposed that in my head as I wrote that down. So we'll just do this. There we go. And then I can also write 71 times this is 5048. Okay. Hopefully I don't start turning numbers around in general. Okay, now, watch this. Just to cut to the chase a little bit, because we're, okay. So what's one possible thing? Remember, we know it's this. What's kind of like the simplest possibility that one of these could be? 2, sure. Let me see. Is that one? Yeah, okay. So couldn't one of them be x minus 2? Couldn't it? Does it have to be? No. So watch. How would I figure out, if that was, how would I figure out what this other stuff is? I could divide this by this. I could take this and divide it by this. And how do I do that? Exactly like we did over there. Oh man, I'm gonna make a lot of friends today. Okay. Don't forget this. What are variables again? What are variables? What are they? What do they represent? Numbers. So how do they have to act? The same way numbers do. Exactly the same way, because they are freaking numbers, yes? So watch this. Okay. I know some of you guys are going to turn off immediately. Don't. Just fight it. Here, watch. So let me set up the division. Okay. Yeah, Jeff, that looks exactly like what I wanted to see. I really want you to realize this is not that bad. You ready? What did we do here for? Didn't we look at the 7 into the 50? Yes. So look at the x minus x into x cubed. X into x cubed. X times what is x cubed? X squared. Right? It's just like when we wrote the 7. 7 times 1 is about 57. And then what did we do? That times this, and we put it there, yes? So what is x squared times x? X cubed. And what is x squared times negative 2? Negative 2x squared. And then what did we do? Change the sign, right? Change the sign. Okay. Change the sign. So everything we just did, how did I do? 7 goes into 50 about 7 times. X, or even better, 7 times what is about 50? 7 times 7 is about 50, right? X times what is x cubed? X times x squared is x cubed. Then I multiply this times this. Because what I do here, I multiply 7 times 71. X squared times x is x cubed. X squared times negative 2 is negative 2x squared, right? And then what is the next general thing we do with all long division? We change the signs. Don't we? That wasn't 497, a negative 490, it's 497, and then I change the sign. So what's x cubed minus x cubed? What's x squared plus 2x squared? Say again? 3x squared. Bring down to negative 10x. And then what did we do here? Didn't we say 7 into 7 goes once? So what do we do here? X times what is 3x squared? 3x. 3x times x is 3x squared. 3x times negative 2 is negative 6x, right? And then I do what? Change the signs. Do you see how it's exactly the same shit we did with numbers? Because all these are numbers. They have to act the same way. These cancel like they always need to. Negative 10 plus 6, negative 4, bring down the 8. Oh my God, Jeff, I love this shit. X times what is negative 4x? Negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 2 is 8. Change of signs. 0.
Okay.
So what does that mean? What does that mean? Did it go in evenly?
Mm-hmm.
Yes. So this, from what we just did, this is x minus 2 times this shit, right? Do I have to do long division again, or can I just factor this crazy thing? We can just factor this, right? All right, Jeff, calm down. So this will be x minus 2 times, how does this do? X plus 4 minus 1.
And you could use any of those factors of 8?
That's right. Now what really sucks, and why we want to develop, do you guys wish there was a shortcut for this?
No.
Okay, so you never use the shortcut. Everybody else, we're going to learn a shortcut to this. If you use it, you get points. I'm joking. Okay. So there is a shortcut, thank the gods. There is a shortcut. And I'm going to show it to you right now. The shortcut only works, okay, this is important, okay. Shortcut only works if the bottom is a linear with coefficient 1. And that's why the shortcut so kicks ass, because it's so restrictive. It says you can, if you're going to divide by x plus 7, shortcut works. If you're going to divide by x squared plus 7, leave the shortcut alone. It can't help you. Too bad. You have to do long division. Maybe. So let's talk about the shortcut, because that seems really important. Seems like something we want to know. By the way, do you guys realize we just factored something that would have been impossible for you to even think about factoring about 30 minutes ago, right? If I gave you this and I said factor this, you all would have been like, after a second, you had to, what the shit does this guy want? And we just did it. Right? But what if we would have picked this wrong? What if we would have tried to do x minus 8? Would it have worked? No, because x minus 8 is not a factor. The long division would have had a remainder. Do you see how that would suck? If I have to do this multiple times until I get lucky and get the right number from here? So we want a shortcut, please, dear God. Okay, so let's talk about the shortcut. I don't want to do this. I want to put it over there. Okay, long division shortcut. Please. Oh yeah, I have new markers. So let me just tell you what this is called and see if anybody might have heard of it before. Actually, does anyone even know what this is called? The shortcut to long division? It's called synthetic division, right? Bum, 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 bum. So, do you notice? All right, real quick. What are the most important things that came out of here? All the stuff that led to these coefficients were the most important thing. Watch this. If I divide a cubed by a first degree, isn't the answer going to be a squared? Doesn't that make sense? So I already know the answer is going to be a second degree. Do you guys all see that? If I divide a cubed thing by an x to the first power thing, the highest power of x left alive will be a squared. Yes? So I already know that shit. This is even not important. These coefficients are what's important. And where did those come from? This shit doesn't matter. This always cancels. I want to develop a shortcut where I'm not writing this shit because it's always going to cancel. See how every time I cancel? Every time I cancel. Why would I want to write that shit? What's the important stuff? Isn't this important right there? 1 plus 2 is 3 because that's where the 3 came from, right? This is a 1, that's why this is a 1. All right, so watch this. Let me do it. Yeah, I can erase this. So the shortcut, please, I'm going to put it here. I want it to be right next to the long division. So here's the shortcut. So 2 things really suck. I got all this extra shit that I'm writing that makes it really long, yes. And I have to remember to change the sign every damn time, correct? So what I want to do is I want to develop a process where I just don't even write the variables. They don't matter at first. All I need to know is what the coefficients are going to be. So the way we set this up, so I'm not going to write x. I would write -2, but I don't even write -2. What I do is, instead of changing the sign each damn time, I'm going to change the sign right at the beginning. So when I see x minus 2, I'm going to put a 2. So I'm changing the sign one time, right at the beginning, instead of every damn time, right? And again, and now I'm still not going to write any of my variables. I'm going to write all my coefficients of my problem in order. So what's my coefficients? 1. 1, keep going.
10,
-10,
8.
8. This is so crazy simple, it's almost hard to believe it's the same process as this. Okay. So whatever number this is, that's what this number is going to be. If this would have been a 2, wouldn't I have put a 2 here so that it would multiply to be 2 something? So this number, whatever this number, and by the way, I do have a handout. This number just drops down. And then you do this, you ready? Because didn't I do 1 times 2 to get this 2 here? Right?
Yeah.
So then you do 2 times 1 is 2, and then you add. Right? You multiply, put that there, add. By the way, 1 plus 2 is 3, right? 1 plus 2 is 3. Multiply, 2 times 3 is 6. Add. -10 plus 6 is -1. Right? You with me? So we're only capturing the important stuff. Long division is long because I got extra shit I don't really care about that I'm writing. I gotta write it, but I don't care about it. Multiply. Add. 0 remainder. So the last number is always the remainder. And how do I read this off? Well, it started with an x cubed, so this is the coefficient of x squared, like we talked about earlier. So this is x squared. Now it just goes down by 1. 3x minus 4. That's the same answer we got there. And that is called synthetic division. So let me give you this handout. I've got the steps, I've got a long division problem, and I got the steps for synthetic division. Synthetic division kicks so much butt. It's insane. Yeah, my poor printer is almost at it. Harder to read at the end of this. Sorry, guys. Oh my goodness. I think you can read that. If you can't, let me know. I'll get some more ink. So let's try. So that is a handout you can have sitting next to you. And by the way, this is section 5.4. 5.4 is just long division and synthetic division. So if I were you, I'd have that handout sit next to me as I do the homework, right? Let me erase this. Anybody ever done Let's think about grammar. Has anybody ever done synthetic division before?
Yes.
Few of you guys, okay.
Real time ago.
Long ago. So real quick, guys. Oh, this could come out gross, okay? This could come out so gross. Let's see. I don't know what's gonna happen. All right, so let's do this one together, I think. And you guys are gonna help me set this up. Is synthetic division allowed here? What tells you it is?
Linear with coefficient one.
Yeah, linear with coefficient 1, slope 1, right? So the minute, if I put a squared, I have to do long division. If I put like a 4 here, I could do synthetic, but maybe we'll do that in a minute. So, help me out. I call this, I don't really watch much hockey, but I call this the penalty box for some reason. Just felt like I'm just putting this guy over there. Anybody remember what's gonna have to go in the penalty box? -3, yes. Right?
Why is it -3?
Because we're not considering the x's, and I want to change this sign once instead of each time. So we're not considering the variables, we're not even writing the variables, right? But I want to change the sign once at the beginning instead of each damn time, like we did in a long division. So it's not, it's 3, and then I'm going to change the sign. So I only have to do it once now. And what am I going to write here?
All the coefficients.
What I?
3, -2, +5, 1, -2.
Okay. All right, you guys take a minute. Go ahead. Let's see. Let me look at it here. Oh, this is gonna get gross pretty quickly. Oh well. Oh well. Too bad. Wait. Before you guys get too far, let me see. I'm gonna try to make this better. Make that a +2. Make that a +2 right there. That should be minimally better. Sure, just a little bit better. All right, make that a +2. So this just comes down. So I'm gonna kind of catch up to you guys. 2 times this, you add, maybe 7 times this, and then you add. Right, the number's gonna get a little out of control. 26 times this, 78, is that right? And then you add, and then the best one of all, 77 times 3. Is it 231? What is that? 231, I think, yeah. Okay. All right, so the numbers get out of control a bit sometimes. You got calculators. So can you interpret the answer then? This would be 3x to the what power? Careful. What did it start off as? 4th power. I'm dividing by first power stuff. The highest power that should be left alive is a 3rd power. Yes. So it always goes down by 1. And then you just sort of keep going in order. Now, how the hell do I write that thing? Oh, shit. No. In fact, remember, how do I write 18 over 5, 5 into 18 goes 3 times, 15, 3. How would I write that? It would be 3 and 3 fifths. So, do you understand what the and is plus? So when you see 3 and 3 fifths, it's not 3 times 3 fifths, it's 3 plus 3 fifths, correct? We just chose, unfortunately, to just smush them. So here, how do I write that? This will be plus 229 over, what did we divide by? What did we divide by? Yes, x plus 3, right? X plus 3. Crazy shit. So that means if I took this and I multiplied it by this, I would get this. Crazy shit. Now, real quick, let me show you something really cool right now while this is up here. Can somebody help me out? Let me call this guy, I'm going to call this guy P of x, or polynomial of x, yes? Just the top, right? Can somebody real quick, what is P of negative 3? Can you guys just put a negative 3 into this top piece and see what it is? Just, can anybody do that? That has a calculator instead of just a hand? Whoa, wait a minute. I did something. Darn it, this is not going to be as exciting as I wanted to because, let me see, did I make mistakes in here? Oh, is it? What did I do? Oh, negative 3, Jeff. I'm doing freaking 3. All right, that makes it better. So 229?
I think so.
It is. That's what it should be. I'll put a 3 in instead of a negative 3. Good job, Jeff. And do you see how that's exactly this? Do you guys see that? Every time, if I'm given a polynomial and then divide it by something like this, that means that if I were to plug that number in, it would come out to be the remainder. That's called the remainder theorem. That's crazy. Jeff, you can do it. So real quick, I want to do one more example that's a little bit tinier. Let's do a tinier example, Jeff. And it's got a specific issue happening. Sure. Sure. Okay. There's a specific issue with what I've given you. X squared is missing. So if I go to put the penalty box, I put a 2 in there, right? I can't do this. This is not right. This is so not right. This is dreadfully not right. Because I didn't get all of the coefficients. The coefficient of the cube is 1. What's the next thing down? Coefficient of x squared. What's the coefficient of the x squared? 0. Coefficient of the x, and then the number term. So if you're missing one of the terms, you have to put a 0 there because that's what the coefficient would be. So see how this comes out. 1, 2, 2, 4. No, I didn't. Okay, good. I thought for a minute I made one that actually worked. I didn't want one that worked. Okay. Of course it wasn't going to work. That's true. Is that cool, everybody? So here's what's really kind of nifty. All right. So again, what would this be? 1 in front of x to the what power? No, it was x cubed. I divided it by x something, so it's going to be x squared plus 2x plus 5 plus 5 over x minus 2. Now, what I want you to realize, and I don't know if you guys ever looked at remainders like this, but when I do a 7 into, who cares, 25, right? What's that remainder really mean? It means this thing was 4 bigger than something 7 would have gone into. So this thing is 5 bigger than something that this would have gone into directly. Now watch this, so watch this. Do I want to, nah, it's all right. I'm not. No. So if I would have put a minus 10 here, the remainder, do you see how the remainder would have been 0? So that's another way to interpret the remainder is how far off this was from this going into it evenly. That's what the remainder really means. Okay. Gracious shit. Okay, I like it. Okay. So just to kind of show you where we're headed. Oh, this could be exciting. Let me see. I need something that's going to work. I can't create that on the fly. Hold on. There it is. Okay, good. That'll work. Okay. Plus x minus. Okay. So if I ask you to factor this, the only method we knew before today doesn't work, correct? Just like we saw earlier, grouping won't help. But now we have a nice shortcut way to test certain numbers. Exactly which numbers could work, which nice whole numbers could work. Or not whole number, integers. Remember we made that list earlier? The possible zeros. I didn't call it that, but remember, what could be the things that would go in here? Remember, we made that list earlier. Plus or minus? 1, 2, 3, 6. Okay. How many numbers is that?
4 or 8.
8. So I'd have to test possibly 5 of them before I finally get one that works. But now that we have synthetic, it's pretty quick. So somebody pick a number out of this list. 2. And what do I put here?
1, 4, 1, minus 6.
So let's see, 1.
Do you flip the sign of the 2?
Well, you just want to pick 2. So this would, what would this relate to? This would relate to what factor? X minus 2. Good.
Okay, all right. Just clarify.
You're good. I'll do this kind of quickly. Right. Multiply, add, multiply. Do you see how this is not going to go in even? So 2 didn't work.
Try negative 2.
Try negative 2. 1, multiply, add, multiply, add, multiply. Woo! Sorry. Now, this would be what? This would be polynomial. What is this?
X squared.
X squared.
Plus
2x plus 3. And then you can just factor that directly, yes?
Yeah.
If this was a bigger monster, meaning this would be a bigger monster, I would still not be able to factor it. I could just kind of keep going right here. I could just put another thing, and I don't remember what that. But now look at this. I can kind of eliminate 6 is no longer an option, right? Do you see that?
Mm-hmm.
So I don't know. You can try another thing right there. You can try another thing right there. You keep going, right? But this is not, I don't have to do that because this is just a quadratic. I can factor that directly, right? I don't need any synthetic help. Okay. Every time I do this, I always think about Fallout 4. The Institute. Nobody in this one. Any questions on that? I mean, so a few of you guys, this is familiar to, and many of us forgot just how to do long division, period, because it's been a while, which I can understand. So, and again, just to remind you guys, if I said to divide this, could I use synthetic division? No. And real quick. I'll do one more thing and then I'll let us out of here. I said earlier, like, so if I had this, 4x minus 3. You're gonna be really excited about this. I could still do synthetic, but could anyone figure out what you would put here? I appreciate that. And again, what do we put here? Isn't it, if the bottom was x minus 7, wouldn't I put a 7 here? Isn't it what makes this 0? So watch this. If I factor, now watch this, okay. If I take a 4 out, because the problem is the first number's not a 1, right? That's the problem. So if I take a 4 out, oh, then I could put a 3/4 here. Doesn't that sound exciting?
No.
No.
That's the right answer. But again, synthetic would still work, is the point. You just have to use the right thing. This has to be a 1. Now, what that means is the answer you get would then have to be divided by 4. Because when you do that, you've only divided by that piece. And then you also have to divide by 4 still. Yes. All right, that's, okay. I can't remember if that comes up or not. In your homework, it might. Okay, that's plenty. Everybody got a practice test, right? So I have an answer for you for that on, what is it, tomorrow, somehow. And we'll have a review tomorrow. I'll have the quizzes graded. Cool. Okay.